So again, is it recording? I think it's recording, yeah. Okay, so happy Tuesday again. Today, we talk about binomial random variable. And afterwards, we will talk about Poisson distribution. That's another type of distribution. This will wrap up essentially chapter 7, okay? Now, before we do binomial uh, distribution, we need to first do a test and make sure that what we have in front of us is indeed a binomial random variable. And for that purpose, we need to do a test where the answer of all 4 questions has to be yes. Okay, so first question would be, is that a fixed number of trials? So we have to have a check on that one. Then does each trial has only 2 possible outcomes? So essentially complement events. Like tossing a coin, it would be head or tails. Then accordingly, the probability, so one of the 2 events we will call success, the other one we will call failure. And so the probability of success is called P. Probability of failure would be then 1 minus P. In the example of the coin, assuming it's a fair coin, probability of heads would be 50%, which makes the probability of tails also 50%. And then the trials has to be independent, so we have to have that path independency, meaning that past number of success versus number of failure has no influence on the probability of future success and failure. Okay, so if in the past if we flipped a coin, for example, 100 times, and then we had 53 times tail and 47 times head, that does not increase or decrease the probability of the next time I'm tossing. It's still, 50-50. Once we have all those boxes checked, essentially, we know it's a binomial random variable, which means that we can use this formula here. Just as a reminder, n was the number of trials, x was the number of successes, and P is the probability for success. 1 minus P obviously is the probability for failure. So I can calculate, for example, out of 10 times tossing the coin, what's the probability of having exactly 4 times tail, for example, right? So that's the stuff that I can calculate. And then we did this example, which was a student who is doing a test, and he has not studied, and the student decides to simply randomly cross some answers, hoping that enough answers are correct to pass the exam. The exam is assumed to have exactly 10 questions. Each question has 5 correct answers. Again, the student pure randomly answers those questions. What we did next is we calculated, for example, what's the probability of the student having exactly 0 correct answers. So number of successes to be exactly 0, and n is equal 10 again, because there are 10 questions essentially. Each question is like a trial, right? Each question has 5 answers, and the student just randomly crosses one of the answers. We can look here, for example, what's the probability that Pat gets no answer correct? And so essentially we enter for x 0, and for n we enter 10. So we did that already, and for obviously probability of success is here 0.2, because each answer has 5 answers, A, B, C, D, E, and only one of the answers is correct. We did the math and we figured out it's 10.74% probability of success. Then we looked into this other case. We looked, for example, what is the probability that 2 answers are correct, right? We did all that stuff, right? And we also calculated for 1 and 3 as well. Is that correct? Do I remember it correctly?
Yes.
Yes? Okay, cool. So it works essentially the same, only for x we insert now 2 instead of 0. N is still 10, of course. The exam has still 10 questions, and the probability for the correct answer has not changed. And we figure out that the probability for x is now 30%. And so essentially we could make a probability distribution for this trial, right? The probability distribution would look something like this, right? So if you look here, probability of 0 was 10%. Let's think of this area being probability of 0. This is 1, This is 2, this is 3, and 4, and 5, and so on, right? So as you see, probability for 0 was essentially 0.1074 or 10.74%. Then we calculated the probability for 2, and as we saw, the probability of having 2 correct answers is 30%. So 0.3020. Does that make sense? And then we also calculated probability for 1 correct answer. I'm pretty sure we did that in the previous class. So we saw that probability for 1 correct answer was 26.84%, 0.2684, and so on and so forth, right? So probability for 3 correct answers, we also calculated that, and you see here, probability for 3 correct answer is again about 20%, and so on and so forth. Probability for 4 correct answers goes already down to like 8%. So it's already pretty unlikely. And then having 5 or more correct answers becomes extremely unlikely. Okay, we can calculate all of these probabilities by simply plotting in the different numbers here into the formula. Does that make sense? Give me a thumbs up if that is clear, or ask me your question if it's not clear. So every time I say give me a thumbs up if it's clear, it means please ask a question if it's not clear at the same time. Okay, wow, a lot of thumbs up. That's awesome. I like it. Here was the question that was asked. What is the probability that he has less than 50% in the quiz? Less than 50%, because we are dealing here with discrete distribution, probability distribution. Less than 50% is the same thing as saying 40% or less. Okay, 40% or less, so 4 out of 10, so 4 or less success is the same thing as saying strictly less than 5. Okay, so that's essentially what's happening here. So when we want to calculate the probability of 4 or less, what we need to do is calculate the probability of 0, plus the probability for 1, plus the probability for 2, plus the probability for 3, and plus the probability for 4. Yeah, from 0 to 4, that would be, if we add all of these together, we calculate the cumulative probability essentially from 0 to 4. Okay, what's the probability that you have 4 or less correct answers? And so if we do the math, we figure the result here is 90.9672, which is equivalent to 96.72%. Okay, so 96.72% is the probability that you have 4 or less correct answers. Now, there is a faster way of calculating it than plugging into the formula. If you go into your books, and if you go pretty far to the end of the book, you have to go to the page, essentially Appendix B. That Appendix B will become now very important throughout the semester, okay? Because in Appendix B, you have a bunch of tables. We can use these tables to figure out the probabilities. It's obviously much faster. Once you know how to read the table, it's much faster than using the formula. It doesn't mean that the formula is useless, because these tables can help us only with, you know, the typical probabilities, and so they can help us with certain probabilities and also with certain number of trials. If we have something a little bit atypical, then these tables won't help. Look here. This is the page that I was talking about. So this is what you should be able to see. Okay, it says Appendix B. And then it says Table 1, binomial probabilities. That's the tables that we're looking for. So every time we are looking at the binomial distribution, we should use the binomial probabilities table. So that's the first part. The second part is then we have to, as you see, there are different tables. We have to find a table with the right number of trials. Okay, so if you see at the beginning of each table, you see some n. Here it says n equals 5, n equals 6, n equals 7. Those are the number of trials. Now, the one that we were looking for is, you know, the exam has 10 questions, so that's like the number of trials that we're looking at is 10. So if you go 2 pages further, because the page after is like n equal 8 and then n equal 9, but then the page after that, you will see here on page B3 in your book, you will see n equal 10. So that's the right table that we are looking for, okay? So that was the second step. Once we found the right table, then the third step is to find the right column within the table, okay? So now we have to look for the right column. And in our case, we had P, probability of success, was 20%. So this is the right column that we are looking for, the column for 20%, okay? So we have to first find the right table set, which is binomial tables. Then you have to find the right table within the table set, which was the table with n equal 10. And then the right column within the table, which is here p equals 0.2. And last step is to find the right value in the column. Now, if you look back, we calculated the probability of having exactly 0 correct answers. We put the numbers in the formula, and the probability was 10.74%, or we calculated 0.1074, which is equivalent to 10.74%. And this is exactly what we see here. Does that make sense? Because then we look into K. K is here actually our X. Okay, what says here in the table K, that's the number of successes. Okay, so the probability of having 0 success, so K0 is 0.1074, and that's exactly what we calculated. But now let's take a look for 1, for example, right? Look, we calculated for 1, the probability of 1, you see here, 0.2684, 26.84%, correct? But now let's take a look here in the table, and you will see something a little bit surprising. If you look here, it's again n equal 10, 0.2. The probability for 1, it's a different number here. It's 0.3758, right? It's a different number. We had here, again, 0.2684. That's what we calculated with the formula. If you look in the table, it's 0.3758. Does it mean that the formula or the table is wrong? No. Why do we observe different values? The reason we observe different values is that the value that you see here in the table is cumulative value, right? So this 0.3758 means the probability of having 0 or 1 correct answer. In other words, this number is the probability of having 1 or less correct answers. This one is a probability of having 2 or less correct answers. If you look, for example, when we calculated here the probability for 4 or less correct answers, x equal or smaller than 4, it was 0.9672. Now let's take a look here on the value for 4. We will see the same, 0.9672, right? Because this is cumulative probability. Probability of having 4 or less correct answers is 96.72%. So the question is, or let me throw at you guys the question, how do we calculate if you want to know only the probability of having exactly 1 correct answer?
Subtract it from 0, like subtract the 0.3758 minus the 0.1074.
Exactly, very good. Exactly, so we have to take 0.3758 minus 0.1074. Let me do it really quick for you guys. 0.3758 minus this number, 0.1074, and then what we see is it's 26.84%. And that's exactly what we calculated. You see here in the left, P1 equals 0.2684, and that's the number that we get here as well. Is that clear? Thumbs up if it's clear. Okay, so this concept, to understand this, is very important, right? Because now we can answer all kinds of questions. We can answer the question, what's the probability of having more than 3 correct answers, between 2 and 6 correct answers, strictly larger than 2, but equal or smaller than 7 correct answers. All those kind of questions can be calculated super easy by just doing a very simple, just subtracting 2 numbers or something like that, right? So that's essentially how it works. So here, let me repeat it one more time briefly. So this is how we do the table. We have to first find the right table with the right number of trials. In our example, we had n equal 10, so we have to find the table with n equal 10. The next step is to find the right column within the table. In our question, we had probability of success was 20%, so we have to find the column with 0.2. The next step is we have to look into the accordingly into on the left hand side to find the correct n, but also we should keep in mind that n is a cumulative probability, which is not a problem with zero, because this zero means the probability of having zero or zero essentially correct answers. But if you're looking for example, the probability for two correct answers, right? What you do, you take the probability of cumulative probability of two correct answers and you subtract the cumulative probability of one correct answer. And that has been done here. So cumulative probability of two correct answers is 0.6778 minus 0.3758, and then the result would be 0.3020. And then if you look here, that's exactly what we calculated before. Probability of two correct answers, look here, 0.3020. Okay, so this is essentially how we use the table. And I would like to now practice it with you guys a little bit. Here's another example. One might ask, so for example, what's the probability of having 4 or less correct answers? That's what we calculated, is 0.9672. Okay, in other words, it's only a 3.28% chance that you have more than 4 correct answers, 5 or more correct answers. So as you see, probability of having more than 7 correct answers is 0.0001, right? Because with 99.99% probability, you will have 7 or less correct answers in that exam, okay? And so on and so forth. So it's pretty much impossible to score an A or a B or whatever, or even a C, or a D, if you haven't studied and you just do it randomly,